Hi everyone, we're going to pick up on chapter 6 on the concept now of mass percent composition. This is an idea that's going to be important later on. So if we want to know what is the formula for a new compound, for example, we're going to need to use this concept of mass percent composition. And there's two ways to calculate mass percent composition, which is given in these two sections right here. So the way you do this experimentally is shown in that definition in the notes. The way you would do this is you would usually take your compound and then you would decompose it. So decompose just means you heat it until it breaks apart into its elements. And then you would weigh that specific element. So for example, element X, take the mass of that element X and then divide it by the mass of the entire sample that you originally start with. And if you take that and multiply it by 100%, you get your mass percent of element X. So if you remember in the previous video, I had talked about this bicycle analogy to how to calculate number of atoms from a compound. We can use the same analogy to illustrate the idea of mass percent. So for example, let's say every bicycle has two wheels. And in this case, let's say the mass of both wheels combined together is 3.3 pounds and the bike itself is 14.5 pounds. So if you want to calculate the mass percent of the wheels, you would take 3.3 divided by 14.5 times 100%, which gives you 22.8%. Okay, let me show you now example B right here. And it says there a 35 grams sample of a compound is analyzed in a lab, and then it is determined that it consists of 5.21 grams of phosphorus, the remainder being chlorine. And the first question is just determine the percent by mass of phosphorus and chlorine in this compound. So to do that, you just need your definition of percent composition that we just learned. That is, you would take percent P would be mass of P over mass of the compound times 100%. Mass of P in this case is 5.21 grams. Mass of the compound is 35 times 100%. And this should give you 14.9%. So that's for phosphorus. For chlorine, we're going to need the mass of chlorine, which we're not given, but we can calculate it. So mass of chlorine is just going to be the total mass of compound, which is 35, minus the phosphorus. And then when you do that, you should get 29.79 grams. So once you get the mass of chlorine, you can calculate the percent for chlorine. The mass of chlorine over mass of compound times 100%, and that's now 29.79 grams over 35 grams times 100%. The grams cancel away. This is a unitless quantity. You get 85.1%. Okay, so that's how you solve number A. For B, it says what mass of PNCl would be found if you have 1.88 grams of this compound. So this is really using that same definition of percent mass composition and then just solving for something else instead of the percentage. So the way I would solve this for percent P is remember that percentage means that it's the same percentage whether you have a lot of materials or a little bit of materials. So in this case, the percent would be the mass of P over the mass of compound times 100%. Well, the mass of the P we don't know. We're trying to solve for that. The mass of compound in this problem, it says 1.88 grams times 100%. Well, we know that that thing is supposed to equal 14.9%. That was what we got earlier. At this point, what you need to do then is solve for mass of P. That means you're going to need to multiply both sides by 1.88. That would cancel out your 1.88 with this one, and then divide both sides by 100%. And so now if I rewrite that a little bit better, I'll see mass of P is going to be equal to 1.88 grams times 14.9% over 100%. Your percent cancel, and your unit in the end is just going to be grams. That would give you 0.280 grams. Now, one thing I want to point out here about this is if you look at this equation right here, which is the equation we just derived from our percent composition definition. And what that is really just taking the percent of phosphorus and expressing it as a decimal. what we did here is we took the percent of the phosphorus and we divided by 100, which becomes just 0.149. So another way I could write this to solve this problem earlier would be 1.88 grams times 0.149. And 0.149 is just the percentage of phosphorus expressed as a decimal. So that's how I'm going to solve for the other problem, which is the mass of chlorine. There are two ways to solve this, but the first way I'm going to do this is just to take the same mass of compound and then multiply that by percent of chlorine in decimal form. Well, the percent of chlorine from my earlier calculation was 85.1%. So I'm just going to write that as a decimal, which is 0.851, and that would give me 1.60 grams with correct sig figs. Another way to solve for mass of chlorine is to take the total mass of the compound, which is 1.88 grams, and then subtract out the mass of the phosphorus, which we already calculated, and that was 0.280 gram. I also get 1.60 grams. So what we just talked about is how to calculate the mass percent composition if you actually do an experiment and get masses for both your element and for your compound. But it turns out that it's also possible to calculate mass percent composition from a chemical formula. So you don't actually need to do an experiment. And so the way we do this is given in this equation right here. To calculate the mass percent of element X, if you have the formula, is you take the mass of element X in 1 mole of compound. Another way to say that is you need the molar mass of X, and then you have to multiply that by how many X you have in the formula. Okay, so number of X in formula. And then what you do is then you divide that by the mass of 1 mole of compound, which really just means the molar mass of the compound. And then take the whole thing, multiply by 100%. Okay, so let me show you how this works. The bottom here you see the example question. It says calculate the mass percent of Cl in CCl2F2. Percent chlorine is going to be the molar mass of chlorine times how many chlorines you have in the formula. Well, there's 2 of them, so it's 2. Now it's really 2 moles here is what the number is, but we're just going to use 2 right now, divided by the molar mass of the compound times 100%. If I look up the periodic table, I find that the molar mass of chlorine is 35.45 grams per mole. As I said earlier, the 2 is really 2 moles because there's 2 moles of chlorine in that formula. And then over the molar mass of the compound. Well, the mass in 1 mole is 120.91 grams. The moles cancel out, the grams cancel out, times 100%. That gives you 58.64%. So let me show you one example. To do this with acetic acid, it says calculate the mass percent of oxygen in acetic acid, and they give you the formula of acetic acid right here. So percent oxygen in acetic acid. Well, again, we would do the same thing, molar mass of oxygen times number of oxygen in compound over molar mass of compound times 100%. The molar mass of oxygen, if you look at it on the periodic table, it's about 16. In acetic acid, we have 2 moles of oxygen. And then the total molar mass of acetic acid is 60 grams in 1 mole. So we just write 60 grams. Cancel, cancel, multiply this by 100%, and you should get 53.3%. Now, sig fig here, I'm being a little liberal with this. In theory, I should use more significant figures for my molar mass for both of these. And if you do that, then your final answer would have 3 sig figs. 3 sig figs is typically a safe one to use for these percentages.